the graph of a quadratic function is called a parabola. And a parabola, you'll see the graph on the right there, is kind of like a U shape, all right? Each parabola has an axis of symmetry, and the axis of symmetry is going to run down the center of our parabola. So you'll be able to basically fold the parabola in half over the axis of symmetry. So the axis of symmetry runs right down the center of our parabola. Each parabola will have a vertex. The vertex is the point of the graph that touches the axis of symmetry. So that would be this point right here is going to be my vertex. Let's take a second here. Let's look at this box underneath our graph. Let's start filling in some of this information. First off, it's asking me what is the axis of symmetry. So we drew that dotted line down the center. What is the x value that our dotted line is going through? It's going through the x value of -2. Okay? Our vertex is an ordered pair. What is this ordered pair of this point right here? That ordered pair, the x value would be -2, the y value would be -1. So our vertex for this quadratic function is -2, -1. Okay, that vertex is going to either have a minimum or a maximum value. Okay, a minimum value would be the lowest point on the graph. Okay, if a parabola has a minimum value, my parabola is going to be opening upwards. So you'll notice that if we look at our parabola, our arrows are pointing up. Okay, that is opening upwards. So this parabola has a minimum value. Okay, if our parabola had a maximum value, if the vertex was a maximum value, that would mean it was the highest point on the graph, and our graph would be opening down. This example. A model rocket is launched from the ground after a 3-second countdown. The vertical distance d of the rocket, as it travels over time t in seconds, is represented by the parabola shown. You'll notice that time is our x-axis and vertical distance is our y-axis. What is the maximum vertical distance of the rocket? To answer this question, we want to look at the vertex of our quadratic function. The vertex is this point right here. The vertex is at 618. So the maximum vertical distance is the y value of that point. The maximum vertical distance of the rocket is 18 meters. Each quadratic function is going to have a y-intercept, and the y-intercept is the point of the graph that touches the y-axis. So let's look back at our picture here. That would be this point right here. Where is my graph crossing the y-axis? That would be at 3 is my y value, so the ordered pair would be 0, 3. The domain of our quadratic functions, similar to what we've done before, our domain is going to be all real numbers. Okay, so we can fill that in our box over here on the right as well. Our range, remember range is y, so it's all the y values that are included. So if we look at our picture, what is the lowest y value? Okay, that's going to come from our vertex up here. Our vertex is a minimum, so my lowest y value is at -1. Okay, my lowest y value is at -1, which means everything else, all the other y values are going to be above -1 because my parabola is opening upwards, it's going up. So my range is going to be y is greater than -1. Okay, so that's a lot of terminology, a lot of pieces of a parabola of a quadratic function that we're looking at. So the next thing that I want to do is I want to be able to find all of this information, not just from the picture, which is what we just did, but also from the equation itself, okay? So my next example here that we're going to look at, we are going to use the quadratic function y equals -2x squared minus 8x plus 6. Okay, we're going to be finding all of the same things, but instead of having a picture to reference, we are going to do this just with the equation that was given. So before we begin, let's go ahead and determine our a, b, and c. Remember, a is the coefficient of x squared, so that would be -2. B is the coefficient of x, in this case it would be -8, and c is my constant, which is 6. All right, so to find our axis of symmetry, we have a formula that will be used to find that. All right, so x equals -b over 2a is the formula that can be used to find the axis of symmetry. So we just stated what our a, b, and c was, so we just need to plug these numbers into our formula. So we have -b, so I'm going to keep my negative sign. I'm going to plug in my b value, which is -8, divided by 2 times our a value, which is -2. So my numerator is +8 because the two negatives cancel, divided by -4 for my denominator. So my axis of symmetry is equal to -2. All right. Next, we need to figure out our vertex. Now, the x value of your vertex is actually really easy. To find the x value of the vertex, it is the same as your axis of symmetry. So my axis of symmetry was -2, which means the x value of my vertex is also -2. Now, we have to do some calculations to find the y value of that vertex. So to find the y value of the vertex, we want to substitute the x value of the vertex, that -2, into the quadratic function and solve for y. So again, my quadratic function from up there was -2x squared minus 8x plus 6. So we're substituting -2 into this equation. So I've got -2 times -2 squared minus 8 times -2 plus 6. Now, you can do some mental math here and work all this through. You can type this entire thing into your calculator, and it's going to give you a value of 30. So the y value of my vertex is 30. Okay, next let's determine our minimum and maximum from our equation. So to determine minimum or maximum, we don't have the picture. We can actually use our lead coefficient. So if our lead coefficient is greater than 0, the graph is going to have a minimum value, meaning it's opening upward. That's its lowest point. If the lead coefficient is less than 0, that means our function has a maximum value. The vertex is at the top and your parabola is opening down. So let's figure this out for our example here. Our a value was -2, my lead coefficient. -2 is less than 0. So because it is less than 0, that means this parabola is going to have a maximum value at its vertex. Okay, next we've got the y-intercept. So our y-intercept is, and this is really awesome, always the c value. Okay, whatever your c value from your function was, that's the constant term, is what your y-intercept is going to be. So my c value, if you remember, was 6. So my y-intercept is at 6. So the ordered pair would be 0, 6. Remember, we said the domain was all real numbers. And our range was determined from the y value of our vertex. So the y value of my vertex was 30. Okay, and we know that 30 is the maximum point. So that's the highest y value that I'm going to reach, which means all of my other y's have to be less than or equal to 30. And actually, with that being said, if we scroll back up here a little bit, our range up here, it should have been y is greater than or equal to -1. I apologize for that. All right, so what we just did here is exactly what we're going to have to do in order to graph these quadratic functions, which is the next thing that we're going to look at. All right, graphing our quadratic function. Find your axis of symmetry, find your vertex, minimum and maximum, y-intercept, domain, range. We're going to find all of this information, we're going to create a table, and we're going to graph the quadratic function. All right, so for our first example here, y equals x squared minus 4. My lead coefficient here in front of x squared would be 1, so a is 1. Notice there's not an x term, which means b is going to be 0, and c, our constant, is negative 4. So to find our axis of symmetry, we have negative b divided by 2a, so we have negative 0 divided by 2 times 1, which is 0 divided by 2, which is just 0. So my axis of symmetry is 0, which means the x value of my vertex is 0. Okay? We'll substitute 0 into our equation. 0 squared minus 4. Calculate that. You can do it mentally. You can use your calculator. Gives me negative 4. So my vertex is at negative 4. And I just want to point out real quick, once we know our vertex, we're going to take our vertex and we're going to go over to our table here. Our vertex goes in the middle of our table, okay? So we'll come back to that. Let's go ahead and finish answering all these questions. Next question, is the vertex a minimum or a maximum point? We use our a value to determine that. Our lead coefficient, our a value, is equal to 1, and 1 is greater than 0. So if our lead coefficient is greater than 0, our parabola is going to have a minimum value. You can reference back the front of your notes for that. Okay, y-intercept comes from our c value. Our c value is negative 4. So our y-intercept is 0, negative 4. Domain is always all real numbers. And then our range. So our range comes from our vertex. So negative 4 is the y value of my vertex, and that's the minimum point. So my y values have to be greater than or equal to negative 4. All right, now let's move over to our t-chart. All right, so we need some more x values in here. And what we're just going to do is we're going to build around 0. So if I start at 0, we're going to go up 2, so 1, 2. And we're going to go down to negative 1, negative 2. So to find our corresponding y values, we want to take our x's and plug them into our equation. So again, our equation was x squared minus 4. So I'm going to take negative 2 squared minus 4. You're welcome to use your calculator. Do it mentally. That gives me 0. Plug in negative 1 squared minus 4 equals negative 3. Plug in 1 squared minus 4. That again equals negative 3. Plug in 2 squared minus 4. That's going to equal 0. Okay? One thing I want you to notice, look at these values. Notice that they match, okay? Because of the symmetric nature of a parabola, when you put your vertex in the center of your table, those points on the left and the right should match up for you. Let's go ahead and graph. So we've got 5 points to put on our coordinate plane here. Negative 2, 0, negative 1, negative 3, 0, negative 4, 1, negative 3, and 2, 0. Okay, we can see that shape forming. And our parabola here is opening upwards, and our vertex is our minimum point there at negative 4. All right, got 2 more examples to go through for you. Okay, y equals negative x squared plus 2x minus 3. So let's determine our a, b, and c. The coefficient of x squared is negative 1, so that's a. Coefficient of x is 2, that's my b. And my constant is negative 3, so that's my c. We're going to find our axis of symmetry. It's negative b divided by 2a. So plug in your numbers. B was 2. A was negative 1. So this simplifies to negative 2 divided by negative 2, which is equal to 1. So my axis of symmetry is 1, which makes the x value of my vertex 1 as well. Let's go ahead and find the y value of my vertex. So my equation was negative x squared plus 2x minus 3. So I'm substituting the x value of my vertex, the 1, into this equation. Notice that negative that was in front of the x squared stays out there in front of my parentheses, okay? You can type this into your calculator, do it mentally. You should end up with -2. So the y value of my vertex is -2. Take your vertex, put it in your table. 1, -2 is going to be my vertex. All right, is my vertex a minimum or maximum point? We have to use a to figure that out. So our a value, our lead coefficient, was -1. If -1 is less than 0, so if your lead coefficient is less than 0, your vertex is a maximum point. Our y-intercept comes from C. C was -3, so the y-intercept is the point 0, -3. Our domain is all real numbers, and our range comes from the y value of the vertex, which was -2. We know that -2 is our maximum point. That's the highest that my parabola is going to go, which means my y's have to be less than or equal to -2. Okay, so let's go ahead and take our function, -x squared plus 2x minus 3, and we're going to fill out our table here. So if our middle x value was at 1, we're going to go up 2 to get 2 and 3, and we're going to go down by 2 to get 0 and -1. So those are the x's that we're going to substitute to go ahead and find our y values. Now, I want to point out, if x is 0, you already know the y, because that was where your y-intercept was. So here our y-intercept was at -3. So 0, -3 is a point I already know. And if this point is -3, so is this one. So I actually only have one thing I need to calculate. Let's calculate when x is -1. Keep that negative out in front there for me. Okay, you can plug that into your calculator. Looks like we get a value of -6. So the first and last values in our table are -6. Go ahead and plot your 5 points on your graph. And graph your parabola. You're going to notice that it's opening down, which makes sense because we said the vertex was a maximum point, which it is there at -2. Okay, one last example for you. Y equals 2x squared plus 8x plus 1. So A is 2. B is 8. And C is 1. Find the axis of symmetry, -b over 2a. So we have -8 over 2 times 2. So I've got -8 divided by 4. That's going to give me an axis of symmetry of -2. Which means the x value of my vertex is -2. Let's find the y value of our vertex. We're just going to plug -2 into our equation. Okay, find out what that equals. Should get -7. So my vertex is -7. Put that in your table. -2, -7, and we'll come back to that. Is my vertex a minimum or maximum point? Well, let's compare our a value. A was equal to 2, and 2 is greater than 0. So, lead coefficient is greater than 0, which means I have a minimum value. Y-intercept, always C. C was 1, so my y-intercept is at 0, 1. Domain is all real numbers. Our range comes from the y value of the vertex, which was -7. And -7 is a minimum value. So all my other y's have to be greater than or equal to -7. Okay, let's create our table. Build around the -2 in our x column. So we're going to go up by 2. So we've got -1 and 0. And down -3 and -4. Okay, remember what I said about the 0 value in your table. We're finding the y-intercept. So if x is 0, we already know y is 1. So if y is 1 down here, y is 1 up here at the top of our table as well, which means we only have one calculation to do. Let's use -3. So I've got 2 times -3 squared plus 8 times -3 plus the 1. Go ahead and calculate that. You should get a value of -5, which puts negative 5 down here as well. And just go ahead and graph. And there we have our parabola. It's opening upwards because our vertex there is a minimum value.